This algebra review lesson is on quadratic equations. And a quadratic equation is one in which the variable is squared. So we can have what we call a quadratic expression, not an equation, but just a mathematical expression such as this: x squared plus 8x plus 15. And we see the variable x appears there. It appears a couple of times, but in at least one of those places it is squared. That's what makes this a quadratic expression. By definition, a quadratic expression is one in which the variable is squared. And we can do a lot of things with quadratic expressions. We can factor them sometimes. This particular quadratic expression would be x plus 3 times x plus 5. If you did a FOIL multiplying those two binomials, you would get this original quadratic expression. And being able to factor expressions like that is very helpful if you're trying to solve equations. We can graph a quadratic expression. If we made a graph, something like this, a function f of x is equal to x squared plus 8x plus 15. I've just taken this expression and written it as a function, and this means that the value of the function depends on what number we put in here for x. And we can put in a bunch of different numbers for x and get out a bunch of different values for the function f. And we can graph this on an xy plane. Saying f of x is equal to this is the same thing as saying y equals this. These two statements there mean the same thing. Y is just the y value or the height of the function. And if we graph a quadratic function, we get a parabola. That means if we start over here on the left side and we go all the way over to the right, and each step across the way we get a different x value along here. And each time we plug in those x values into this expression and do the arithmetic and calculate a value for f or for y, the height of the function, and plot that point, we get a parabola. So quadratic expressions can be factored, they can be graphed, and quadratic equations can also be solved. For example, if we had something like this. Here's a quadratic equation. Maybe we had x squared minus 8x plus 2 equals 0. We want to solve this for x. We want to find the values of x that we could plug in right there and there such that this equation would be true. Solving a quadratic equation is an important thing because a lot of things in the real world are described by quadratic equations. So they're important from a practical standpoint as well as from a theoretical standpoint. A cannonball being lobbed through the air, for example, moves in a path that is a parabola. It's described by a quadratic equation. The cables on a suspension bridge take the shape of a parabola. They're described by a quadratic equation. And so to be able to make these things and use them and understand them, we need to understand quadratic equations. Quadratic equations are often in this form where you have the variable squared and then the variable and then the constant term and then equals 0. They're not always in that form though. We could have something like this. We could have x minus 4x squared equals 8, and we might have to manipulate it algebraically to put it into this form with the x squared term first and then the x term. If it's written this way, that's sometimes referred to as the standard form. We would call that ax squared plus bx plus c. This could represent any quadratic equation, just different numbers for a, b, and c. Could give us any quadratic equation in the world. And we need to be able to solve these, and we'll go over different techniques for solving quadratic equations. Some of them are a lot easier than others. And the last thing here in this little introductory segment I'll mention is the term quadratic. When you see the word quad there, you think 4. And so some people ask, why isn't a quadratic equation one in which the variable here is raised to a power of 4? That would make sense. Call a fourth degree a quadratic. And that's a very reasonable question. When you think quad, think of the 4 sides of a square. A square has 4 sides. And it's related to the Latin word quadrare, which means to square. So linguistically, the term quadratic is related to the word square. So that's why we use a quadratic to represent things in which the variable is squared. So now those are the introductory comments. Now we'll look at some techniques for solving quadratic equations, and I'll just go through a list of a lot of examples and talk through each step and show you the thought process for different types of quadratic equations and how to solve each one.